In this video, I'm going to go through OCR AS-level Chemistry, and this is paper 1. This is the 2016 paper, and I'll just do the first half of the paper in this video and the second half in a later one. Okay, question 1, which shows the atomic structure of 37 chlorine? Well, we need to look in our periodic table and see that chlorine is atomic number 17. So it's going to have 17 protons, so it's either going to be A or B. Well, how many neutrons has it got? Well, it's 37. 37 minus 70 is 20. And it's a minus there. That's why it's got an extra electron. That's why it's 18 electrons, Cl minus. Okay, so that is the right answer. What's the formula of ammonium sulfide? Okay, so we need to know the form of the sulfide ion. Well, sulfur is in group 6 of the periodic table, so it's going to be 2,6. So it's going to form an S. It's going to gain 2 electrons to form the S2 minus ion. That's the sulfide ion. Ammonium, we should know that is NH4 plus. So you're going to need 2 ammoniums for every 1 sulfur. So the formula is going to be NH4 2S. It's because ammonium is only a single positive and sulfide is double negative. So C is the right answer there. Calcium nitrate decomposes when heated is shown below. And the student composes this many moles, 0.005, of calcium nitrate and collects the gas. What would the volume of the gas be? Right, well, 1 mole of calcium nitrate gives us 2 moles of NO2 gas and also half a mole of oxygen. So the total 1 mole will give us 2.5 moles of gas. So that means 0.005 moles of calcium nitrate is going to give us that multiplied by 2.5. That's going to give us 0.0125 moles of gas. Right, what's the volume of gas? Well, the volume of gas in centimeters cubed, SDP, is equal to the number of moles multiplied by the volume of 1 mole of gas, which is 24,000 centimeters cubed. So 0.0125 times 24,000 gives us 300 centimeters cubed. So D is the right answer there. Right, okay. Which equation is not a neutralization reaction? They quite often ask exactly the same question, and the answer is A. Okay, all these. So, well, neutralization, you've got to have something accepting H. The base or the alkali has got to accept H plus ions. Okay. So in this equation, the OH minus is accepting H plus. In C, it's the carbonate ion which is accepting H plus. That will accept 2 H pluses and form carbon dioxide and water. All the other things are spectator ions. And what's accepting the H plus here is the NH3, ammonia. Now that's accepts an H plus and forms NH4 plus. But here the calcium, yeah, it's neutralizing the acid, but it's not accepting H plus. Okay, it's actually giving away electrons to the hydrogen. In actual fact, it's a redox reaction. So 4 is the answer. A is the answer to 4. Next question, what's the oxidation number of magnesium in magnesium nitrate? Well, that's easy. Magnesium is always +2 in all of its compounds because it always forms the M2 plus ion. So B is the answer there. How many orbitals are occupied in a silicon atom? Okay, right, so let's have a look. We have got 1s is occupied, 2s is full up, 2p, that's all full up as well, 2p6. Then we've got 3s, 2, and then we have got 3p2. So how many different orbitals have we got? Was 1, 2, 3, 4, 5 is the answer. So A is the answer there. Actually, that's not the answer, because we've got to remember the p orbitals, there's 3 of them, isn't there? So that's not the answer. So we do have one orbital occupied there and 1 there, but we've got 3 occupied there, and then we've got 1 occupied in 3s, and then we have got, we've got to remember we have 2 of those 3 p orbitals be occupied, because the electrons won't pair up unless they've got 2. So how many we've got? So 2 there. So 1, 2, 5, 6 plus 2 makes 8. 8 is the answer. Right, there's a dot cross diagram for nitrogen trichloride, which shows the correct shape and the bond angle. Right, so we have actually got 3 bond pairs and 1 lone pair. So the orbitals are going to occupy basically a tetrahedral shape. So you're going to have N, it's going to form 3 bonding pairs to the chlorines. Of course, the lone pair is more of a bulbous shape like that. Now, if it was 4 normal bonding pairs, that bond angle would be 109.5. But it's quite squashed down from 109.5 to about 107 because the repulsion of the lone pair is greater because of the shape of the lone pair. So, and we describe that molecule as being pyramidal because it's tetrahedral with respect to the orbitals, but with respect to the atoms, nitrogen and the 3 chlorines, it's pyramidal. So 107 pyramidal is the right answer. What is the shape around the carbon atom in graphene? Okay, well, the layers are completely flat and you've got hexagons. Right, so that each carbon atom is the center is right. There's 120 bond angles there. There are no lone pairs, so the shape is trigonal planar. Okay, electronic configurations for different atoms of different elements are shown below. Which electron configuration represents the element with the largest first ionization energy? Well, when we think about the size of ionization energy, really, we're talking about which quantum shell, and then the nuclear charge. Now, as we go across any period, like so for period 2, the general trend, right, the nuclear charge increases, so the first ionization energy increases, and so the elements in each period, the element with the highest first ionization energy is the noble gas. So neon is the one with the highest one in period 2, argon, and so on. Right, so we're probably looking for a noble gas here. Okay. And also we've got the thing about the quantum shell. We've got to remember, right, helium will have a higher first ionization energy than neon because it's closer to the nucleus. It's in the first quantum shell, and the same for neons will be higher than argon and so on. Right, 1s2s2, well, that's going to be beryllium. That won't be particularly high because it's got a small nuclear charge for something in the second shell. It's got a small nuclear charge for period 2. It's further on the left of period 2, isn't it? That's beryllium. Right, B is going to be 2p4. That's going to be oxygen. That's going to be quite high because it's quite a long way along the thing. But this one is going to be higher, 2p6. That's neon. That's got the biggest nuclear charge for period 2. So that's probably going to, and then D, well, that's going to be lower. That's actually going to be magnesium. That's going to be lower on 2 counts. 1, it's in the third quantum shell, further from the nucleus, and magnesium is over on the left-hand side of that period, so it hasn't got a particularly big nuclear charge for period 3. So C is definitely the right answer there. Okay, successive ionization energies for 4 elements in period 3, which could be magnesium. Right, now magnesium is in group 2. It's got 2, 8, 2 is electronic structure. So the first 2 electrons are quite easy to remove because they're coming from the third quantum shell. And the third electron There's going to be a big jump there because that's coming from quantum shell number 2. So if we look at B is the answer, because like, okay, you've got a big jump there between the second and third ionization energy. It goes up by a factor of 4 or something. If you look at the other ones, you don't really get any jumps. In A, there's no big jumps. Okay. In C, you probably get a big jump between the 4th and the 5th there, so that's probably in group 4. And again, for this one, for D, you've got a big jump between 3rd and 4th, so that's probably in group 3. So B is the answer, definitely, for that question. Okay, student adds sodium carbonate to one test tube and aqueous silver nitrate to a second. Right, which row is the correct observations? Okay. The student adds dilute sulfuric acid. Right, let's think. If you add dilute sulfuric acid to sodium carbonate, any carbonate, you're going to get carbon dioxide produced. So you're going to effervescence. So it's either got to be C or D. Okay, the right answer. Now, when you add sulfuric acid to silver nitrate, well, you will get a precipitate because silver sulfate is not terribly soluble. And so if you add sulfuric acid to silver nitrate, you're going to get a precipitate of that. So the Ag plus ions will join up with the sulfate ions and the sulfuric acid to give you Ag2SO4 solid. Okay, so D is the answer there. Okay, 12. The enthalpy change of formation of butane can be calculated using combustion. Okay, the delta H of combustion values. Right, what's the answer there? Now, we're going to use a Hess's law for that. Now, when we're ever given delta H combustion values, the third thing we write down in our Hess's law cycle are the combustion products. So we write down carbon dioxide and water, 5H2O. Which way do the arrows go? Well, you're burning these things to turn them into carbon dioxide and water, so the arrows are going to go down. Okay, let's look at the green arrow first. All we're doing is burning 1 mole of butane, so that's minus 2877 there. And on the red arrow, we're burning 4 lots of carbon, 394, and 5 lots of hydrogen, 286. Right, if you add that lot up together, you get minus 3006. So delta H combustion here. Right, delta H combustion, we are going to follow the red arrow, so you stick with the sign, but we go against the green arrow, so we're going to change that negative to a positive. So delta H combustion is minus 3006, and it's plus 2877, and that gives us minus 129 kilojoules per mole. So B is the answer there. Okay, and if you get your arrows the wrong way around, you'd end up with C. Okay, obviously combustion, formation, no, sorry, it could be positive, it could be negative. Right. Okay, 13, skeletal formulae of 4 alcohols are shown below. Which pair of alcohols are structural isomers? So that means they've got to have the same molecular formula. Okay, so straight away we can get rid of H because that's got a double bond in it, so that's going to have a different ratio of carbons to hydrogens to all the other ones which are saturated. Now we need to just count up the number of carbons in them. So let's see, E has got 1, 2, 3, 4, 5 carbons. F has got 1, 2, 3, 4, 5, and 6 carbons. So E and F is not the answer. And how many carbons in G have we got? We've got 1, 2, 3, 4, 5. So it's only G and E which have got the same number of carbons. So G, E, and G it is. That is the right answer to that one. What's the name of the following compound? Okay, so we're going to number the longest carbon chain, which is, I'm going to start from that end. I'll tell you why in a minute. Okay, 1, 2, because it's got more things stuck to that carbon number 2 rather than carbon number 3. Okay, if I numbered it the other way, I'll just explain there. You could, it would be wrong to number it in the red one. We'll see why in a minute. So how long is it? It's 4, so it's going to be butane. But we've also got stuck to that, we have got chlorines on 2 and 3, so it's 2,3-dichloro. And we've also got a methyl group stuck on number 2, so it's 2-methyl. Now, which one goes first? It's the 2,3-dichloro goes first because that's a functional group, so methyl isn't a functional group. So 2,3-dichloro, 2-methyl butane. Now, if you'd used the red numbering there, you would have ended up with 2,3-dichloro, 3-methyl. When that means you've got higher numbers, so it's wrong. So you should label it in the blue way. Okay, so 2,3-dichloro, so which one is it? C is the right answer there. Which compound has non-polar molecules? Now, you've got chlorines in there, which is electronegative, a lot more electronegative than carbons. So for these to be non-polar, they've got to be symmetrical. Okay, so dichlorobutene. Okay, so let's just draw that. 1,2-dichloro. No. That is not going to be symmetrical. You can see it's not symmetrical, so that's not it. We've got to have the chlorines kind of opposite each other or something. Okay, 2,3-dichlorobutene. Let's try that. 2,3-dichlorobutene, and put these in there. And these are E, so these are opposite. Yeah, Cl, Cl, CH3, CH3. Now that is symmetrical. That is going to be flat, that molecule, of course. That is going to be delta minus, and that's going to be delta minus, and this carbon is going to be delta plus and delta plus. But because you've got this negative charge at this end of the molecule, it's balanced out by the extra negative at that side, so it's symmetrical, so it wouldn't have a dipole. Okay, now if you had Z23, then you'd have to put the chlorine down there, and then these chlorines wouldn't balance each other out. It definitely would be more negative on this side, so it's not that one. And 1,4-dichlorobutene, butene, that's not a possibility either. Okay, for the same reason as A, really. So the answer is B there. Right, displayed formula for hydrocarbon shown below. What's the correct number of pi and sigma bonds? Well, the pi bond bit is easy. There's only 2 of them. There's where the double bonds are. There's one there and one there. So you've got 2 pi bonds. So it could be either B or D. Now, don't forget, when you have a double bond, you don't just have a pi bond, you have a sigma bond. So how many sigma bonds are there in this molecule? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So B is the right answer. Okay. You have a double bond is made up of a pi bond and a sigma bond. Chlorine reacts with 1-chloropropane in the presence of UV light through radical mechanism. Which equation shows a propagation step? Well, for propagation, you've got to have radical reacting with non-radical to give a new radical and a new non-radical. So this one is not right. That's initiation, isn't it? So you've got a non-radical forming 2 radicals. This one is a termination. You've got 2 free radicals coming together and joining up to form a bonding pair. So it's either got to be C or D. Now, D is the right answer there, okay? Because that's, you always form HCl in one of the propagation steps. The hydrogen that comes off joins up with the chlorine free radical to form HCl. It doesn't form a hydrogen free radical there. So D is the right answer. 18. Which alcohol can be oxidized by potassium dichromate and sulfuric acid to form a ketone? Now, what kind of alcohols do that? Of course, it is secondary alcohols give you a ketone. Of course, a tertiary you can't oxidize. And the primary, that goes to an aldehyde, and then one step more to a carboxylic acid. So which one of those is a secondary alcohol? Well, look at the hydrogen is attached, the OH is attached to that red carbon there in A. That's only attached to one other carbon, so that's a primary. Let's have a look at B. There's the carbon which is attached to the OH. How many carbons is that attached to? One there and another one there, two. So that is a secondary. So B is our answer. Let's just check though. This one, the carbon to which the OH is attached is there, and that is attached to 1, 2, 3 other carbons, so that's a tertiary. And then finally, this one, there's the carbon the OH is attached to. It's only attached to one other carbon, so that is a primary as well. So B is the right answer. Okay, reaction sequence is shown below. So we've got HBr reacting with an alkene. Okay, now do you remember that when what happens there, HBr, right, that's delta positive, so that's an electrophile, okay? And you break the double bond, so it's electrophilic, not substitute, it's electrophilic addition. Okay, so step 1 is electrophilic addition, so it's either A or B. Let's look at step 2. We have got a haloalkane there. And we've got a bromine on carbon number 3, or number 2, if you like. Right, that's going to react with OH minus to form an alcohol. You've got a delta positive there. The OH minus is going to do that. That's going to drop. So this is a nucleophile. The OH minus is negative, yeah, nucleophile. And it is substitution, nucleophilic substitution. So the answer is B, electrophilic addition and nucleophilic substitution. Right, when heated with NaOH, one iodobutane is hydrolyzed much faster than one chlorobutane. Which statement explains the different rates? Now, it is not, it is because the carbon iodine bond is a lot weaker than the carbon chlorine bond. Right, so the answer here is this is D. That bond requires less energy to break than the carbon chlorine bond. Let's just go through this. The carbon iodine bond is greater. No, it's weaker than that, so that's wrong. The carbon iodine bond is less polar. Well, it is true. That's true, but that wouldn't explain it. You think you'd really expect it would be more polar than it would be better at attracting nucleophiles. So that it's not the polarity of the bond that affects how fast the reaction goes, it's the strength of the bond. So that one is wrong. And this is the Ci bond has a carbon atom with a greater delta positive charge. Now it's going to be lower, isn't it? Because iodine is not as electronegative as chlorine, so that's wrong for that reason. 20 is D. Okay, so that's the end of the multiple choice section, and I will cover section B of the paper in the next video.